Hello. Today I will be presenting my project on AI and personalized medicine. Before we begin, I would like to give a little bit of background on who I am. My name is Sana Kandasamy, and my Polygence mentor was Kelly Mullane. I'm an eighth grader in Hopkinton Middle School, and I'm presenting from Hopkinton, Massachusetts. One of my passions is writing, which also encouraged me to start a passion project. I chose to do it on AI and personalized medicine because in the past few years, I've seen how much AI has been evolving around me, and I've started to notice how important it is in this generation. So, what is personalized medicine? Personalized medicine is the adaptation of a medical treatment to a patient's needs. Every patient is different, so their needs are also going to be different. Artificial intelligence. Artificial intelligence is a data driven technology that mimics humans' decisions. It learns from itself and its own experience daily. The clash. This leads us straight to our big question. Why is AI useful in personalized medicine? Well, in personalized medicine, there are six processes. Number one, genetic profiling. Number two, genome sequencing. Number three, biomarker identification. Number four, drug identification. Number five, gene editing. Number six, monitoring and adjustment. Number one, genetic profiling. These next few slides are going to focus on a deeper depth into each of these processes. Genetic profiling. A genetic profile is a detailed record of patient genetic information, and it's typically a lot of vast data. It's used to guide treatment. This whole process focuses on establishing this profile. Abilities and advantages of AI. AI is able to perform high dimensional processing, which is the ability to process large amounts of data in a quick amount of time. It's really efficient. Another ability of AI is pattern recognition. Through its own experience and strong memory, AI is slowly able to pick up on specific patterns that can help diagnose the patient sooner. AI is also able to recall important information when it's relevant to the treatment in later on steps. Number two, genome sequencing. This is a little part to genetic profiling. A genome sequence represents the full DNA of a patient. These are always unique to a patient. This means that no patient's genome is going to ever look the same. A genome sequence is DNA written thoroughly through nucleotides. It's the blueprint of life, except it's basically gibberish because nucleotides are ACTG, A for adenine, C for cytosine, T for thymine, and G for guanine. Abilities and advantages of AI. AI is able to perform thorough examinations of the data and outperforms manual methods. An example of one of these manual methods was in 1990, the Human Genome Project. This project focused on writing out the genome of a human, and it took 13 years just to do one human. AI is also able to provide an accurate interpretation through memory and predict treatment. Biomarker identification is also another part of genetic profiling. A biomarker is a characteristic of genetic information that provides insight into patient health. These are useful to track disease progression, but can also be really subtle and hard to find. Abilities and advantages of AI in this process includes preventing overlooking biomarkers in initial stages. It stays aware of the presence of these biomarkers into the later on steps and just keeps them flagged. Number four, drug identification. Drug identification is selecting the correct drug and the most efficient drug for the patient's needs. This involves selecting the right drug, and this is done through drug profiles. These profiles contain background information on the drugs and help select the best drug to satisfy a patient's needs. The drugs are tested to determine suitability for the patient. Abilities and advantages of AI. AI accelerates data processing and identifies key differences of drugs that can make one drug a better fit than the other. Normally, before testing is started, there's a range of drugs that might be suitable for the patient. These differences help cut down the range, which means less testing. Less testing also results in less spending money and less time. Five, gene editing. Gene editing is a whole different approach of personalized medicine. It's still a form of personalized medicine, but allows scientists and doctors to modify mutated sections of a patient's genome, and this is performed through advanced tools. An example of one of these tools is CRISPR-Cas9. CRISPR is a gene in human cells that scientists are able to take advantage of to modify DNA. Abilities and advantages of AI. AI analyzes DNA and identifies mutations for scientists to focus on. Number 6, monitoring and adjustment. This is the process that streamlines all the other processes. It involves continuous patient monitoring, and the monitoring aims to identify treatment deviations. The sooner these deviations are found, the less potential complications can be prevented. Abilities and advantages of AI. AI identifies treatment adjustments and generates treatment plans such as dosages and a lot more. AI is also able to form predictions based on treatment decisions. For example, if there were two decisions that were in the same treatment, AI would have the ability to predict what could go wrong by selecting one choice over the other. Limitations. AI in personalized medicine has its limitations as it relies on complete unbiased data and extensive training. AI has raised privacy concerns and can provide biased information and misinformation. It's important to remember that AI can only provide a strong output if it's given a strong input. AI also has extensive training requirements. This is what makes the machines used in these processes a lot different from the machine AI that we use every day. A glance into the future. AI is already improving accuracy in certain processes and eliminates human error in those processes. It's also optimizing treatment. These improvements lead to better patient outcomes. AI has the potential to elevate healthcare, however, the current limitations that have been stated previously must be overcome before AI can reach its full potential. Thank you for your time.